This is week 5 and 6 of building a rocket engine in my garage until I get hired at NASA. These past couple weeks were really exciting because I designed my own supersonic nozzle and this happened. But before we get to that, I had to clean up my garage and get a workbench put in. With some help from my dad, I got the corner of the garage cleaned up and I got these couple of workbenches put in. For a rocket nozzle, you need some sort of source of compressed gas. So for me, I got this 3-gallon air compressor. This should be able to supply enough air for a few seconds of supersonic flow. Now the air compressor did come with its own shotgun, so let's put it in front of the Schlieren and see what it looks like. Now we want to make our own nozzle, so a Burrup SolidWorks, and this is what I made. Overall the size is pretty small, but it should be able to fit into the air gun. See, at this point I realized I made a pretty big mistake. I didn't actually account for the mass flow that's coming out of the air tank. So I have to calculate that first and then calculate the area of the throat in order to get the flow to reach supersonic speed. To figure out how much air is coming out of the tank, I timed the amount it takes for the tank to go from 110 psi to about 85 psi. And then using the ideal gas law, I can figure out how much mass was lost from the change in pressure. And now actually designing the nozzle, there's 2 important parameters: the area of the throat and the area of the exit. So there are basically 2 equations that you need to make a supersonic nozzle. This one and this one. So everything in this equation is actually a constant. The only thing we really need is the mass flow rate, which calculating from the ideal gas law gives you about 8.3 grams of air per second. This equation gives you the area of the exit, which mainly depends on the ambient pressure and the chamber pressure. This new nozzle is a lot smaller. The diameter of the throat is 2.6 millimeters and the diameter of the exit is 3.2 millimeters. Comparing the old one to the new one, you can see the new one is a lot smaller. I put it in front of the Schlieren and this is what I saw. On this stick, I didn't have the Schlieren aligned correctly, but you can still see the shock diamonds. Using the following equations, you can figure out how fast the exhaust gases are going. For my rocket, the exhaust gases are going at 500 meters per second, or 1.45 times the speed of sound. For next week, I'm going to use this bigger gallon tank for more mass flow, and that means a bigger rocket. Now for next week, I'm going to figure out how I can fill up the bigger tank. I got to figure out how the tubing works and stuff, and then we'll try to make some bigger rocket nozzles using more mass flow, and then hopefully we can see even more of the shock diamonds. So stay tuned for next week, or maybe the week after that. It depends on how long I figure it out.